Laplace transform. If ft is a function for all positive values of t, then Laplace transform is defined as Laplace transform of t denoted as fs equal to integration 0 to infinity e to the power minus st ft dt. This is the Laplace transform of the function ft. Now let's find out some Laplace transform. Laplace transform of some functions. Number 1. Laplace transform of 1. Laplace transform of 1, that is, by definition, integration 0 to infinity e to the power minus st 1 dt, that is equal to 1 by e to the power minus st divided by minus s 0 to infinity. When we will put the limiting values, then it will turn into 1 by s. This is the Laplace transform of 1 equal to 1 by s. Now for the next step, Laplace transform of e to the power at. It is L of e to the power at. By definition, 0 to infinity e to the power minus st e to the power at dt, that is equal to 0 to infinity e to the power minus s minus at dt, that is equal to e to the power minus s minus a t by s minus a 0 to infinity. Putting the limiting value, we will get 1 by s minus a. This is the Laplace transform of e to the power at equal to 1 by s minus a. Now number 3, Laplace transform of cos of 80. Cos of 80 is equal to e to the power iat plus e to the power minus iat divided by 2. All we know is. Now Laplace transform of cos 80 is equal to integration 0 to infinity e to the power minus st e to the power iat plus e to the power minus iat divided by 2 dt. Is equal to integration 0 to infinity e to the power minus s minus ia t divided by 2 dt plus 0 to infinity e to the power minus s plus ia t dt divided by 2. Now half of integration 0 to infinity e to the power minus s minus ia t dt plus half of 0 to infinity e to the power minus s plus ia t dt. We know that Laplace transform of e to the power 80 equal to 1 by s minus a, and Laplace transform e to the power minus e to the power 80 1 by s plus a. Now applying this formula, we can say half of Now Laplace transform of cos of 80 is equal to Laplace transform of e to the power iat plus e to the power minus iat divided by 2. That is half of Laplace transform of e to the power iat plus half of Laplace transform of e to the power minus iat. So we know that Laplace transform e to the power 80 is equal to 1 by s minus a. Similarly, Laplace transform e to the power minus iat is equal to 1 by s plus a. Applying this formula, we can write half of 1 by s of minus ia, half of 1 by s plus ia, and that is equal to half of s minus ia, s plus ia, s plus ia plus s minus ia. Ia will be cancelled out, and 2s, half of 2s divided by a square minus I square a square, that is equal to s by a square plus a square. This is the Laplace transform of cos 80. Number 4, Laplace transform of sin 80. Sin 80 can be written as e to the power iat minus e to the power minus iat divided by 2i. So now Laplace transform of sin 80 is equal to Laplace transform of e to the power iat divided by 2i minus Laplace transform of e to the power minus iat divided by 2i. That is equal to 1 by 2i. By applying the formula, Laplace transform of e to the power 80 is equal to 1 by s minus a, and Laplace transform of e to the power minus 80 equal to 1 by s plus a. We can write 1 by s minus ia minus 1 by 2i 1 by s plus ia. Now 1 by 2i s minus ia s plus ia s plus ia minus s plus ia. Now s and s will be automatically cancelled out. 1 by 2ia divided by a square minus I square a square. That is equal to 2i12 will be cancelled out, a by a square plus a square. Problem number 5. Laplace transform of t to the power of n. This is a very important function. Now Laplace transform of t to the power of n equal to 0 to infinity e to the power minus st if t means t to the power of n dt. Let st equal to x. Now differentiating with respect to t. So s is equal to dx by dt. Now dt is equal to dx by s. When t equal to 0, x equal to 0. When t equal to infinity, then x is also infinity. Now changing the equation 0 to infinity to the power minus x. T means x by s whole to the power n. Dt means now dt in place of dt, dx divided by s. Now 0 to infinity to the power minus x to the power n divided by s to the power n into 1 by s into dx, which is equal to 0 to infinity to the power minus x to the power n into 1 by s to the power n plus 1 dx, which is equal to, this is a constant part, it can be taken out of the integration s to the power n plus 1 integration 0 to infinity e to the power minus x to the power n dx. Now this part integration 0 to infinity e to the power minus x to the power n dx, which is equal to gamma n plus 1 equal to factorial n. So now the expression becomes factorial n divided by s to the power n plus 1. This is the Laplace transform of t to the power n. Laplace transform of t to the power n equal to factorial n divided by s to the power n plus 1. With the help of this formula, we can find out Laplace transform of t to the power, suppose 6, which is equal to factorial 6 divided by s to the power 6 plus 1, that is factorial 6 divided by s to the power 7, which is equal to 6 into 5 into 4 into 3 into 2 into 1 divided by s to the power 7. So, with the help of this formula, so many Laplace transform can be found out, like this function to the power 6 and so on. Now, very important first shifting formula. Laplace transform of e to the power at ft, that means any function ft, if it is multiplied by e to the power at, the Laplace transform of e to the power at ft will be f s minus a, where Laplace transform of simple ft is equal to fs. So if ft will be multiplied by e to the power at, then s will be shifted s minus a times. That means Laplace transform of e to the power at ft is equal to fs minus a. So this is called the first shifting formula. Suppose we are interested to find out Laplace transform of et cos of 2t. Well, if we only interested to find out Laplace transform of cos 2t, which is equal to s divided by a square plus 2 square, that is s divided by a square plus 4, that is by the formula of Laplace transform of cos 80. The formula Laplace transform of cos 80 is equal to s divided by a square plus a square. With the help of this formula, we can find out Laplace transform of cos t, which is equal to s divided by a square plus 2 square, that is a square plus 4. Now, with the help of first shifting theorem, we can find out the Laplace transform of e to the power t cos 2t. So the result will be fs minus s. So simply put, s minus 1 in place of s. So s minus 1 divided by s minus 1 whole square plus 4. Because a equal to 1 here. So in place of s, we have to write down s minus 1. Because if s minus a will be the resultant of Laplace transform of e to the power at ft. Now the proof of the first shifting theorem. Now proof of the first shifting theorem. From left hand side, Laplace transform of e to the power 80 ft is equal to integration 0 to infinity e to the power minus st e to the power 80 ft dt, which is equal to 0 to infinity e to the power minus s minus 80 ft dt. So which is equal to fs minus a, fs minus a, because simply Laplace transform of ft is equal to fs is equal to 0 to infinity to the power minus st ft dt. So similarly Laplace transform of fs minus a equal to 0 to infinity to the power minus, in place of s we have to write s minus 80 50 dt. So in this way it is equal to fs minus a, which is equal to right hand side root. Now Laplace transform of derivative f dash t. So Laplace transform of f dash t is equal to sfs minus f0 proof. Laplace transform of f dash t is equal to 0 to infinity to the power minus st f dash t dt, which is equal to, it is the integration by parts, so it is taken as a first function, so e to the power minus st integration the second, that is f dash t dt 0 to infinity minus integration of derivative of the first minus s to the power minus st, the integration of the second is dt 0 to infinity, so which is equal to e to the power minus st ft 0 to infinity minus 0 to infinity plus s e to the power minus st ft dt is equal to e to the power minus st ft this will be, total limit will be like this. Now f of 0 plus sfs minus f of 0. So sfs minus f0 will be the result. So this is proved. Now Laplace transform of f dash t is equal to sfs minus f0. Now the Laplace transform of f double dash t similarly is of previous value sfs minus f0 minus f dash 0. So Laplace transform of refill dash is similarly is into previous value fs minus f0 is f dash 0 minus f double dash 0. So on like this. Any number of derivative can be found out by this technique. Now Laplace transform of integration 0 to t f t dt, it can be found out fs by s. This is the Laplace transform of integration. Now Laplace transform of t to the power n f t. So Laplace transform of t to the power n f t, which is equal to minus 1 whole to the power n and nth order derivative of fs, where Laplace transform of ft is equal to fs. Similarly, Laplace transform of tft can be found out 1 whole to the power n Now Laplace transform of tft similarly equal to minus 1 whole to the power n means 1 here. So minus 1 whole to the power 1 dds of fs. Let ft is equal to cos of t. Now the expression becomes Laplace transform of t cos of t is equal to minus 1 whole to the power 1 dds of fs means Laplace transform of cos t is equal to 1 divided by s divided by a square plus 1. So s divided by a square plus 1, which is equal to minus 1 square plus 1 into derivative of the s minus s into derivative of this, that is 2s divided by a square plus 1 whole square, which is equal to minus 1 a square plus 1 minus 2a square divided by a square plus 1 whole square, which is equal to a square, which is equal to minus 1 is 1 minus a square, 1 minus a square divided by a square plus 1 whole square is equal to a square minus 1 divided by a square plus 1 whole square. Now Laplace transform of 1 by t ft is equal to integration s to infinity fs ds, where f is equal to Laplace transform of ft.